Hey everyone, and welcome back to PrepFusion. I'm Anish and we are again back with another lecture of Nyquist plot. So most probably this will be either the last lecture or the penultimate lecture of Nyquist plot basically. So we'll be done with Nyquist plot and then we'll start the Bode plots. So in this lecture mainly we'll solve quotient, right? Whatever theory we have learned, we'll try to apply all those things here, okay? So yeah, let's start with the first question. So first question is telling us that origin of 1 plus g of s plane corresponds to which point in the minus 2 plus g of h of s plane, right? Like what does, like we have to map from one point to another point uh, in a like to in both planes, right? So basically origin in this plane corresponds to what point in this plane. So how do we understand? So the best method to understand is that just try to find, like, we know origin, right? So what is my value of g of h of s in origin? Okay, that you find out and then you put that value g of h of s in here and you simply find the mapped value of the origin function from this 1 plus g of s plane to the minus 2 plus g of h of s plane. So basically what you do, okay, you write 1 plus g of h of s equals to 0. Okay, then what does your g of h of s become? Equals to minus 1. Okay, so if it is minus 1, now you simply put this minus 1 here, right? Okay, so basically when this plane is in origin, then g of h of s is minus 1. The value of g of h of s is minus 1. So now I will just simply put minus 2 g of h of s equals to minus 2 minus 1 equals to minus 3. So minus uh, this 0 point, right? This 0 point correspond to minus 3. Okay, now the imaginary point is anyway 0, it isn't changing, right? Imaginary point is anyway changing. So origin in 1 plus, so this may come handy in sometimes, right? So just be careful about that. Origin in 1 plus g of s h of s plane corresponds to minus 3 comma 0 in minus 2. Like this may come in handy in some concept in quotient, right? So just be careful about that. So this is g of s h of s. Okay, so this I need to bring it down a bit. Yeah, now this is fine. So yeah, let me, okay, so like let us do another question. So this question is a bit different. So you have to find the number of encirclements in the minus 1 comma j0 point in the direction of the complex gs and the direction, sorry, point and the direction. Like you have to find the encirclements and the direction of the complex g of h of s plane, basically the g h of s plane, right, by the Nyquist plot of g of h of s. So simply the thing that we have been doing until now, if the Nyquist contour is taken in the clockwise direction, so they have given us the direction, right? Nyquist contour is in the clockwise direction, and what else we have to find? We have to find basically the number of encirclements that we have been doing until now, right, around the minus 1 comma j 0 point. So they want to find the encirclements around the minus 1 comma j 0 point. So basically what do, you know you have the OLTF, right? So what do you do? Simply if you have the first OLTF, so what is the Nyquist contour? Nyquist contour is same, right? Nyquist contour is same. Just copy this. Nyquist contour is like this. As no poles are at origin, right? No poles are at origin. That's why then our Nyquist contour we can draw it like this, right? So it covers the entire right half plane. Okay, covers the entire right half plane. And now where are my poles and zeros? I can see right here I have one right hand zero, okay, and one right hand pole. So if I have one right hand zero, okay, and okay, the pole is around here and zero is around here, let's say. So if I have one right hand zero and one right hand pole, then what can I say? That what can I say? What is my n? n equals to p minus z. So it is like 1 minus 1, okay, which is 0. So my number of encirclements for the first case will be 0. Now around the origin is 0 for the g of h as well. Is this true? This is not true. Not around the origin, around the minus 1 comma 0 point. Now this would have been true for what? This would have been true, okay, when we had to find the number of encirclements around the origin. But this time where I have to find? I have to find the number of encirclements around the minus 1 comma g 0 point. So I am not talking about g of h of s, poles and zeros of g of h of s. I am talking about the poles and zeros of 1 plus g of h of s. I hope you remember, right? That is what my minus 1 point represents. In the previous lecture I gave you the brief summary, right? So basically this would have been true this would have been true for number of encirclements around origin of g of h of s. Now we don't have to, but we don't have to find the number of encirclements around origin of g of h of s plane, right? What we have to find? We have to find the number of encirclements around minus 1 comma 0. For that, what we used to do? We used to find the basically where are my zeros and poles located, right, of the 1 plus g of s. So for minus 1 comma 0, so we have to find, but we have to find this side. We have to find this one, p plus 1 OL and z plus 1 OL. I hope you remember, right? What does this represent? All this I have explained in the previous lecture. So for that, obviously I have to find the 1 plus OL, right? Here, as our OLTP is simple, we can simply find the right hand zeros or pole. Or else if it wasn't simple, what you would have done? You would have used the Routh-Hurwitz criterion, right? So that also you can use, right? That also you can use to find the right hand poles basically. And right hand poles, closed loop poles will be this, and right hand poles simply will be the right hand poles of the OLTP itself. So this is my OLTF. So 1 plus g of s will be simply 1 plus this, and if I add this one, right, add this one, so what happens? Basically s gets cancelled out. I am left with 2 upon 4 minus s. Now directly I can observe here that I don't have any right hand zeros, okay? So z plus 1 plus OL equals to 0 and p plus 1 plus OL equals to 1, right? So now how many number of encirclements I have? I have simply 1, right? 1 encirclements I have, because p is 1 and z is 0. So n of minus 1 comma 0 equals to 1 comma 0, so which is equals to 1 itself, right? Which is equals to 1 itself. So if this is equals to 1 itself, now what is the direction? Like if this is positive, what does mean? P, I write p minus z. So what am I expecting? My Nyquist contour is in the clockwise direction, so obviously I'm expecting it to be in the opposite direction as p is earlier, right? P minus z, so it will be in the anti-clockwise direction, okay? Encirclement will be in the anti-clockwise direction, okay? So yeah, the encirclement will be something like this, right? So now this is the case for this question. Now let's do another question. So this is the 6th. Now let's do 16 questions. We'll do again, repeat the same procedure only, right? Just for the first one I told you what where we can make a mistake, right? Where we can make a mistake. So for the 16 question again, right, I will write 1 plus g of h of s. I will just draw the contour over here again, right? For the 15th question, the actual contour. So the 0 will be not present over here, only pole will be present. Pole will be same, because why? The open loop pole and the closed loop pole are not the closed loop pole. The open loop pole and the poles of the characteristic equation are same. because denote is same. I have repeated this time 100 times, I think. So sigma j omega. This is a S plane, right? So now what about my 1 plus g of h of s, right? What about my 1 plus g of h of s? This given down. So 1 plus g of h of s, right? This becomes simply 6 minus 2s divided by 4 minus s. Okay. Now why do I have my poles and zeros this time, right? My poles and zeros are basically both of them are on the right hand side. Okay, like what I can observe is if I just draw the contour, right, I just copy this one. The pole is at obviously the same place, right? Pole is at same place, it's in 4 itself, but this time I have a 0 as well, right hand 0 as well, right, of the characteristic equation. So it is in s equals to 3. Okay, it is in s equals to 3. It is in s equals to 3, right? So if it is in s equals to 3, what does that mean? That means basically again, right, number of instruments is 0 this time, so n becomes 0. Let me take it. N equals to minus 1 comma 0 p plus 1 plus ol minus z plus 1 plus ol equals to, like, it is simply 1 minus 1 0, right? So this is 0. Now let's do the another question, the 17th question. So this time I have pole at the origin also, right? I have pole at the origin also, so we have to take care of that also. So what Nyquist contour I will choose? I will choose, obviously I will have at the origin itself, right? So just copy and paste. Okay, not this one. What you can do is you have to find the 1 plus g of s, right? 1 plus g of h of s. So 1 plus g of s h of s you have to find. Okay, so what is it? Simply it is s square minus 2s plus s plus 1 divided by s into s minus 2, right? So what it becomes, so here, right, it becomes s square minus s plus 1 divided by s into s minus 2. Okay, s into s minus 2. So this becomes s into s minus 2, right? So if this becomes this one, so what happens now? So like how many zeros we have on the right hand side? If I observe, either you can use the route. Okay, just use this polynomial and put it in route array table and to find the number of sign changes, and according to the number of sign changes the number of roots will be in the right hand side, or you can directly use that uh, formula, right? Siddha Acharya formula, or here you can see obviously there is sign change, right? Obviously there will be roots in the right hand side, there will be 2 roots this time, because like this is second order system, right? So like if you use the Siddha Acharya formula, right, basically z not plus zol 1 plus what would be the zeros. Okay, the zeros will be simply minus b, which is here, minus of minus 1 plus minus b square minus 1 whole square minus 4ac, right? 4ac. So it will be simply something uh conjugate, right? Complex conjugate. So 1 by 2 plus minus j root 3. Okay, so I don't care about the values. Okay, what I care is it is right hand side and it is lying on the right hand side of my S plane. Okay, so it is on the right hand side of my S plane, so obviously it is inside the contour, right? It is inside the contour, so my zeros are inside the contour and I have 2 zeros inside the contour basically. Okay, 2 zeros inside the contour, right? 2 zeros inside the contour. And what about my poles? So like this time, right, my Nyquist contour will be something like this. Obviously I will avoid the origin. Okay, I will avoid the origin, and I have a one pole at s equals to 2 basically. I have one pole at s equals to 2. Okay, if I have one pole at s equals to 2, what does that mean? That means basically, right, like I have two zeros and one pole. These are all closed loop. These are all closed loop, right? So how many number of, so all these are z plus, right? So z, okay, let me write it like this. I have uh two right hand zeros, and how many poles I have? Right hand. Okay, that is inside the contour basically. One, right, this time. So my n will become 1 minus 2, which is minus 1. So minus 1 in the anti-clockwise direction. Okay, so 1 in the clockwise direction. Okay, so as zeros is more than the poles, right? Hence, what does this mean? This means the direction won't change. The contour, this initial contour, Nyquist contour direction, and the mapped contour direction won't change. They will remain same. That's why this is again in the same direction, clockwise direction, right? So yeah, this was basically a bit of brief about this question. This is very simple to understand and very easy to solve, but you have to understand the concept. Like you can solve this question very quickly, but you have to understand the question, right? Understand the question. So these type of question, 1 mark may come, right? May come 1 mark. So let's go to the next type of question basically. So again we're back with a gate question. So again, like this has come up in gate, right? This has come up in gate. Similar type of question. The number of times the Nyquist plot g of s equals to s minus 1 s plus 1 will encircle the origin in the clockwise direction. Now what is the difference here? There it was telling me will encircle the minus 1 comma 0 point. Now what is it telling me here? It is telling me when it will encircle the origin. Now if it is telling me about the origin, so I will only care about the OLTF, will not care about the 1 plus g of s, right? Okay, that's why if it would have asked about minus 1 comma 0, then I have to write 1 plus g of s, right? Okay, so simple, we'll use that formula. Okay, we'll use this formula n 0 comma 0, and it has also mentioned that it hasn't mentioned anything about the Nyquist contour. So first thing is we will assume, like that is a general convention, assume contour in the clockwise direction. Now if we assume Nyquist contour in the clockwise direction, what does that mean? That means this encirclement will be in the anti-clockwise direction, and the formula will be p plus ol minus z plus ol, right? So formula is like this. So what is my p plus? So my transfer function is like this, right? So what I can observe, so let me just copy the Nyquist contour again, not this one, the previous one. I can simply paste this, I think. Can I or can I not? Yes, I can. So again, right, this is the Nyquist contour, right? This is the Nyquist contour, and I can see that I have a pole on the left hand side, and I have a 1 0 at the right hand side. 1 0 is at the right hand side. So here I have 1 0 at the right hand side, right? So if 1 0 is at the right hand side, so my z plus ol equals to 1 and my p plus ol equals to 0. Okay, so n 0 comma 0 anti-clockwise 0 minus 1 equals to minus 1, right? So it is minus 1 in what direction? In anti-clockwise direction. But obviously the question also asked, right, in clockwise direction. They know, right? So obviously minus 1 anti-clockwise means 1 clockwise, right? 1 clockwise direction, right? So yeah, very simple question, right? Very simple. So you can solve Nyquist question in seconds. Like if you have to find from plot. Now if they have asked you to find the stability, and if the OLTF is given, if the OLTF is given, right, and they want to find you the stability, okay, you don't draw the Nyquist plot. Okay, you don't draw the Nyquist plot, you just simply find the stability. I will tell you, right? So that is the one thing. Else Nyquist questions are very easy to solve, and you can solve it very quickly. Just that simple concept is there, right? N minus p. But n minus p of what? That is the most confusing part. So you have to understand that, right? Now let's go to the next question. Basically, the polar plot of an open loop system, stable system, stable. What does this mean? If it is telling me open loop stable system, this means the OLTF has its pole on the left hand side of basement. All the poles are lying on the left hand side of basement. I will write this. Now the closed loop system is, now it has given us the OLTF is always stable and the polar plot is given. Now it is asking us about the closed loop system. So how can we, how can I totally sure short comment about the closed loop? It is not asking about relative stability, it is asking about absolute stability, right? So how to comment about that? So what we can do is, first, what does open loop stability mean? Open loop stable system, open loop stable system basically means that all poles of OLTF lie on the left hand side of S plane. Okay, this is what basically this means, right? Okay, now what other information can we get from this polar plot? Basically, okay, we have done this polar plot multiple times, right? Similar like this polar plot. What information can we get? This is starting omega 0, and the starting represents what type, right? Here what I see, like this is starting from minus 90 degrees, right? So this is type 1, because when there is one pole at the origin, then if you put s equals to 0, other angles become 0, whatever the order is, I don't care. Just that one pole will remain, and that will contribute to minus 90. So all this, I think you are grasping it, right? All this I have explained very slowly in the polar plot video and in the Nyquist also, right? So this is type 1 system. From polar plot we can observe that type 1 system. Okay, first thing, what is the next thing? It is ending at what, angle at minus 270 degrees. Okay, or what you can say is, like, magnitude is 0 and ending at minus 270 degrees. So the order is 3, right? Starting is minus 90 and ending at 270. So I think you are recalling few things, right? In polar plot, what happens when it's starting at minus 90 and ending at 270, minus 270 basically. So yeah, its order is 3. Okay, because 3 times minus 90 is 270. That's why order is 3. I won't elaborate here much further. So this is already covered in polar plot. So order is 3. Why is order important? I will explain it. Also, like, we'll assume, okay, we'll assume that it is only consisting of poles. So this is one thing, we'll assume that it is only consisting of poles, right? Not zeros. Positive has only poles. So this is what we have to assume, right? Even if we don't assume, it doesn't matter, because why we have to assume? Because to find the number of what, zero magnitude semicircle, what we used to do, we used to basically find the number of poles minus number of zeros, open loop poles minus open loop zeros. But here nothing is mentioned about the zeros. So, or what you can do, at the end it is ending at here, right? So this means basically I have, at least at the end, as tending to infinity, p minus z will be 3, because like all the angles will get cancelled out, right? Basically whatever number of zeros I have, let's say, I will tell you, let's say I have like this, s tau 1 plus 1, then s tau 2 plus 1, s tau 3 plus 1, then s I have. Now this is like order 3, but here, right, if you put s equals to infinity, my angle doesn't go to minus 270, it goes to minus 180. So I have to add another pole, s tau 4 plus 1, right? If I add another pole, what happens? My angle goes to minus 270. So at the end, p minus z itself is 3. P minus z itself is 3. So from here also we can understand that p minus z will be 3 itself. Okay, p minus z will be 3 itself. So my p minus z is 3. Okay, p minus z is 3. Like, if you assume no zeros, okay, or you can do p minus z equals 3 itself, that also you can do. Assume no open loop zeros. Okay, so if we do that, basically what I can say, p minus z equals to 3. So 3 semicircles of 0 radius. Now how am I writing this? All this I have explained, right? Of 0 radius in what direction? Like it is p minus z, right? Obviously it will be in the anti-clockwise direction, right? Anti-clockwise direction. Okay, here, right, it is type 1 system, so one semicircle of infinite radius in what? In clockwise direction. Okay, in clockwise direction. Okay, so as like there, obviously it was going in the anti-clockwise direction, right? Anti-clockwise, because around the 0 0 we avoided the 0 contour, right? This contour, I hope you remember, right? We avoid this contour, so it was going in the from minus pi by 2 to pi by 2. Okay, if you can't recall, just draw the contour. It was going from minus pi by 2 to pi by 2, hence here it will go from pi by 2 to pi by 2 to minus pi by 2, right? So yeah, let me just hold on a second, right? So yeah, sorry for the interruption. Basically, like I have like one call came up, important call. So now, right, what we can understand is like all this we understand. Like the other things we understand. We needed 4 curves, right? One curve is already given, polar plot. The other curve is mirror curve, inverse polar plot, which will be from this polar plot itself, mirror image of this one. And the other 2 curves were the infinite radius circles and the 0 radius circle. 0 radius circle I got from here, right? From the p minus z information. I told you how to derive it, right? And the type we got from this one semicircle of the radius. Obviously, we'll assume no open loop zeros. We'll assume this no open loop zeros, right? Like even if you don't assume, then also your p minus z will always be 3. Okay, that is understood. So let's draw the polar Nyquist plot basically. Have I drawn it? No. Imagine of GeoBase surface, right? So now, like, what is my polar plot? Polar plot is something like this, right? Okay, so this is my polar plot. This is my omega equals to 0, and this is my omega equals to infinity. So I will not, I'll write it later. Let me complete the inverse polar plot. So the inverse polar plot will basically something like this, and we have one infinite radius half circle, right? So it will be obviously like I told you, right, from where it starts and where it ends. It starts from this inverse polar plot, right, and ends at this normal polar plot, right, at 0 plus basically. So this is omega equals to 0 plus, and we know it is in the clockwise direction. From there also we can understand that it is in the clockwise direction. So it will be something like this. Okay, and what about my 0 radius circle? 0 radius, I had 3, right? 3 0 radius, so I'll have to delete a bit of here. Obviously that is for just representation, it doesn't matter, the 0 radius, right? It doesn't matter, okay. So basically it will be something like this. It is in the like this is in the clockwise, so it is in the anti-clockwise direction, right? And it is starting from where? So what happens to the theta is from plus pi by 2 to minus pi by 2. Here it becomes 3 pi by 2, like minus 3 pi by 2 to plus 3 pi by 2. So minus 3 pi by 2. Minus 3 pi by 2 is where? This is pi 2 minus this minus pi, this is minus 3. So it starts from this angle and it goes in the anti-clockwise direction, right? So if I just draw it, it's ends, oh no, not here, it completes circle here, it ends around here, right? And this one starts around here. Okay, it doesn't matter actually much, this one starts around there. Okay, so yeah, like my polar plot goes like this, it goes like this, then it goes like this. Okay, then it goes like this, and it goes like this and like this, right? So basically what is this point? This point is omega equals to infinity plus. What is this point? This point is omega equals to infinity minus. And this point, right? This point is omega equals to 0 minus, basically. So it starts from this 0 minus point and like ends to this 0 plus point, right? I have told this in like one of the short notes. If I just go back to there, so that like every concept is getting used to show you that every concept is getting used, right? Where was it? Yeah, starts from where my mirror image ends. Basically, where does mirror image end? At omega equals to 0 minus, right? That's where my mirror image has ended, and ends where my actual polar plot starts. Okay, I hope you understand this. So yeah. So where is it? So this is this. Yeah, this is the polar plot basically. Now what is this point? This point they have given us very cleverly, right? This is minus 1.42, the point where they are crossing each other, right, at the on the real axis. So this point is minus 1.42. So this will decide everything basically. Minus 1.42, right? And my minus 1 comma 0 point will lie somewhere around here. Minus 1 comma 0 point will lie somewhere around here, right? So now this is the critical point. Obviously they are asking about the stability, right? So what information we know? Information we know that P plus of OL equals to 0. This one we know, which is equals to P plus of 1 by OL, right? That we know. Now obviously we have to find about the stability, comment about the stability. So we have to find the Z plus, right? Z plus of 1 plus OL. Now we have to find the encirclement around the minus 1 comma 0, right, for stability basically. So what we'll do, how many encirclements are there? So obviously I am assuming a clockwise Nyquist contour. They haven't given us anything, so I'm assuming a clockwise Nyquist contour, right? So that is first thing. So should have written it here. So if not, it is not written, obviously by default we consider clockwise Nyquist contour. This is by default, right? So if you consider clockwise Nyquist contour, what does that mean? That means like my number of encirclements should be anti-clockwise. That is a positive one, right? So this is one in the clockwise direction, one encirclement in the clockwise direction, another encirclement in the clockwise direction. So I'm getting n equals to minus 2, right? N equals to you can say n equals to minus 2 in the anti-clockwise direction, or n equals to 2 in the clockwise. But as I am expecting in anti-clockwise, right, this is my positive sense, so I will write n equals to minus 2 because I'm writing p minus z, right? So that is what I will write. So minus 2 equals to, so I will write, that is a simple formula. What formula am I using? It is n minus 1 comma 0 equals to p plus of 1 plus OL minus z plus of 1 plus OL. Okay, so this, right, this becomes p plus of 1 plus OL. What is p plus of 1 plus OL? P plus of 1 plus OL is basically, what is it? It is 0. 5 am laughing, so yeah, didn't have enough sleep. So this is 0. And what is z plus of 1 plus OL? Z plus of 1 plus OL is what is we need to find basically. So this is z plus of 1 plus ol. These are the closed loop poles. So here, right, I can get that z plus of 1 plus ol equals to 2, right? 2. So I have two right hand poles, right? Closed loop poles. Like that means my system is unstable. System is basically unstable, right? Just hold on a second. Yeah, system is unstable, right? System is unstable. So which option will be correct? It is unstable with one pole on the right hand side of the spline, unstable with two poles on the right hand side of the spline. D option is correct, right? So here we wouldn't have been able to use the Routh. Okay, we wouldn't have been able to use the Routh-Hurwitz criteria. Now, for example, let's say if this plot was also given and plot and OLTF is also given, if both is given, right? If both of them are given, then what does this means? This means basically that we can use the Routh-Hurwitz criteria, right? Use Routh-Hurwitz, okay, simple Routh-Hurwitz. If it is a third order, you can solve it in seconds, right? So use Routh-Hurwitz and you will do it much better if you are comfortable with that. Okay, so if you are not comfortable with Nyquist, because in Nyquist you have to plot and then do other things, right? So if you are comfortable with this, you can use Routh-Hurwitz criteria, right? So use, okay, by RH you might think this is right hand, so no, use Routh. That you can use, right? So yeah, that is what I'm telling. I will show you if some example is also here, right? Now this is the next question. So in this question, what you have to do, like they have given the polar diagram is given, that is in the next page, but let's read, of a conditionally stable system. Conditionally means it depends on some condition, right? Whether it will be stable or unstable. Okay, that's what condition means. And which condition it depends, here it is given, right? So we'll read the question. So the polar diagram of a conditionally stable system for open loop gain of k equals to 1 is shown in the figure. Okay, polar plot for k equals to 1, open loop gain, basically the system parameter, right? So like how is my OLTF defined? OLTF is defined like this, right? So I will write this, OLTF equals to k into g of s into h of s. Okay, and I'm varying k. Okay, and like k equals to 1 is g of s into h of s simply. So I'm varying k and this plot is getting varied. How is it getting varied? What is it getting varied? I will explain everything, right? So the polar plot for k equals to 1 is given. Okay, the open loop transfer function of the system is known to be stable. If the open loop transfer function of the system is known to be stable, then what I can decode that my p plus of OL equals to 0. Okay, the right hand side of the open loop poles are 0. Okay, that I can decode. And the closed loop system is stable forward. So for what condition my closed loop system will be stable? For that I would find out few conditions. So with the help of Nyquist plot I can find. First let me complete the obviously Nyquist plot, because it's only the half part. The polar plot is given, right? Only the polar plot is given. Like what I can observe is this again a type 1 order 3 system, right? So again, right, what will happen, that there are zeros also. You can see, right, there are zeros also here, but at the end what is happening, p minus z becomes this 3 only, right? So this 0 is contributing some positive angle, right? Okay, as I explained in polar plot, what happens, like if there is some 0, so it contributes some positive angle, then again this dominance of the 0 is go over and the pole again dominates, right? Hence we are ending at minus 270. So I explained, right, in the previous example with that, but at the end my p minus z will be simply what, p minus z will be 3, as I explained with the example. So here, right, how many half circles will I have? The number of half circles of 0 radius will be what, 3, right? See, and number of infinite radius half semicircles will be what, will be 1, because this is a type 1 system. This is starting from here, right? Type 1 system. Sorry, like in the question it should be mentioned that this is omega equals to 0. Like this is understood, still they should be mentioned, this is omega equals to 0 and this is omega equals to infinity plus. Okay, 0 plus and infinity plus. Okay, so this is the case. Now let's complete the polar plot basically. So I'll just draw the mirror image. This, oh no, this will be difficult. Everything is difficult nowadays. So this is the polar plot. Now I'll just keep this one here. Just understand that this is the intersection of these two. Okay, and it goes like this. Have you understanding why is this like this? We have a 0 here, right? That's why. So yeah, this also you should be able to comprehend. We have studied this so well in polar plot. This also you should be able to comprehend it. So this is like this. Oh no, this will not go away. Shit. This will. Oh, why is this together? I don't understand. Now it is. This is this. And this is this. This is going like this. So it is basically going here. And we have what? 3 0 radius semicircles, right? Which is starting from where? Again, it is starting from what? Minus pi by 2. Minus 3 pi by 2, right? So it is starting from here. Okay. Basically where my polar plot ends, right? Basically where my polar plot ends, it starts, and where my mirror image starts, right, it ends. So it's the opposite of the previous one, right? No, where my polar plot ends, I'm sorry. So it will be something like this, right? So it will be starting from minus pi by 2, and it is in the anti-clockwise direction. So this is 1/2 circle, and this is 2/2 circle. Okay, I may have drawn the previous one incorrectly. Okay, sorry for that. 1 3, yeah, it will be something like this. Sorry, I may have drawn the previous half circle incorrectly. Even it doesn't matter that much, but this here it was 3 half circle. I only drawn like 1 half circle. Okay, so the 1.5 half circle, so it went wrong there. Okay, I have to delete this. Let me draw the axis first. This is 2 half circle and this is third half circle, right? So it is ending where it should end. No, this is third half. It should end here, right? It should end at minus plus 3 pi by 2. What is plus 3 pi by 2? Basically pi by 2, pi and plus 3 pi by 2. So yeah, that's why I was doing it wrong. That's why I was thinking something is wrong, right? Something is wrong. So rotating like this, right? And ending here. Okay, so yeah, this is like this. Yeah, that is it. And here also it will end here, right? And here, right, my where my mirror image of polar plot ends. Okay, it goes like this. So this will be in the anti-clockwise direction, right? Here I have the axis. Okay, so it will be something like this. Now the direction of this mirror image will be something like this. Okay, in the clockwise direction. And yeah, this is it, right? So now what should we do? Basically, right, we got all the information. Now these are my critical points. Basically, let me mark the critical points. This is one of the critical point, this is one of the critical point, this is one of the critical point, right? They have given us 3 points. Okay, so let me mark them, like I will mark them differently. But first, let me like, now what is the question asking? Question asking is when is it stable for different values of k. Okay, so I have to vary k and see when is it stable. So when will it be stable? When will it be stable? It has told us that POL plus is 0. Okay, if POL plus is 0, this means P plus of 1 plus OL is also 0, right? If P plus of 1 plus OL is also 0, what does this mean? This means basically that my n around minus 1 comma 0 in which direction? In anti-clockwise direction, basically has to be minus z of 1 plus OL, right? Now for stability, obviously 0 has to be like this, z plus 1 plus OL has to be 0 as it represents the closed loop poles. Stability, okay, as it represents the closed loop poles. What does this mean? So n of minus 1 comma 0 has to be 0. Okay, it has to be 0 for stability, for closed loop stability. Okay, so now from here, when is my number of encirclements 0? Like I will obviously cross through this real axis, right? And I will see where is my number of encirclements 0. If I am at this point, how many is the number of encirclements? If I at this point, my number of encirclements 1 and 2, right, in the clockwise direction, it is minus 2, but still it is not 0. Okay, so in this region, okay, I will just copy this one because I don't want to mess around with this one. Oh no. In this region, right, in this region, n is not equals to 0. Okay, now what about this region? In this region, n is equals to what? One anti-clockwise encirclement and another clockwise encirclement, right? So what we can see in this region, number of encirclement is 0. So if my critical point lies within this region, then my system will be stable. So somehow my critical point should lie in this region. That is what I am trying to find out, because I have to find the range, right? I have to find the range. So in this region, number of encirclement is 0. Okay, if my critical point lies in this region, right, that is what I am trying to explain. If my critical point lies within its region between minus 2 to minus 0.2, then it will be this, but not minus 2 to minus 0.2, because I am varying my k as well. I'm just trying to tell like what is the region, not the exact values. The values will change. I will explain. Right now, if I lie within this region, what will happen? If I lie within this region, basically, what is my n like n one clockwise road encirclement and another clockwise road encirclement if I lie within this region. So here also my n isn't 0, right? And if I lie within this region on the left hand side, right, on the left hand side, if I lie within this region, then what happens? Obviously I don't have any encirclement, right? So here also my n is 0, so I'm good to go. Here also my n is 0. Okay, so if my critical, if I I lie in this region, I mean that if my critical point lie in this region or in this region, if my critical point, so somehow I have to make my critical point in this region or in this region for my system to be stable. So I will name this regions, right? Let's name this region as A. Okay, let's name this region as B. Okay, I will color this differently. What should I color? Green is also used. Everything is used, man. I should use white. Let's name this region as A, B, then this C, okay, C, and this D. Okay, so what I'm observing is like those are not exact values. Exact values will change. So just let me solve the question, you will understand. If I lie within region A and what, C, if I, not I, now I will say if my critical point minus 1 comma 0 lies within region A and C, then n is 0, hence system will be stable out, right? Hence system will be stable. Okay, this is the first case. Basically this is the first case, right? So if my system is stable, what does this mean? So like this means system is stable. So like my poles will lie on the left hand side, right? Closed poles. So how will I make my critical point lie in this region? So what is the value of my critical point? So value of my critical point is what, minus 1 comma 0, right? Okay, those are the coordinates. So it is basically minus 1. Okay, so basically what I'm varying this g of s of s, right? G of s of s, right? So here the value, the magnitude of g of h of s at this particular frequency, right, it is what, minus 8. It is minus 8. So I want to vary it further. So I am in this region, right? So I want like what do we observe? So this is the plot of what, g of h of s. This is the plot of g of h of s. Now what are the values here? So this point value has minus 2. What does that mean? So for that particular frequency, this point value is minus 2. So initially I mentioned, right, my OLTF is kg of s. So if my k is 1, then this point is minus 2. Let's say if my k is 2, what happens? If my k is 2, what happens? Simply it will get scaled by 2, right? It will get scaled by 2. So this minus 2 point will be minus 4. Like this intersection point will become minus 4. Simply scaled. As my k is 1, so g of h of s is minus 2 at this state. Now if I make my k 2, then k times g of h of s is the magnitude, right? K times g of h of s is the magnitude, right? K times g of h of s is the magnitude. Now g of h of s has value 2, magnitude is 2. I'm multiplying a 2, then what happens? This becomes minus 4, right? This becomes, magnitude becomes doubles, magnitude doubles. So everything is scaled, right? So everything is scaled by k. The plot will be scaled by k. The plot will be scaled by k. So I can simply scale the plot by k. So what I will do, I will just write here these different regions as k, right? Functions of k. It will be similar for easier for me to understand. So this region of the two intersections is minus 0.2 k. Okay, let me write this in white color or some, okay, because this is confusing again. And this is minus 2k, right? And this is minus 8k, right? So if my k is 1, so yeah, this is fine. This is like previous one as showed in the question. If my k is 2, what will happen? Everything will get scaled by 2. So everything will shift to this side, right? If my k is 2, okay. If my k is 0.5, it will try to die down. If my k is 0, what does that mean? If my k is 0, obviously I don't have any plot. So everything will go down to here, right? Everything will go down to origin. So from this analogy is also, you can, I hope you get it, right? What happens if my k varies to the extreme ends? K becomes 0, this went to this here, right? Goes to origin. If k increases, this also becomes bigger, right? Bigger, magnitude becomes bigger. Okay, that's why this expands. So I have get it. Now what is this region? This region is basically, what is the value of this region? Minus 8. So minus 8k, right? So if my critical point lies within this region, then it is fine. So I want E. What is the A region? A region is basically from minus 8k. Okay, now my A region basically lies minus 8k to what, minus infinity, right? And what about my C region? C region lies between which two? Between this minus 0.2k to, no, not minus 2k to minus 0.2k. So minus 2k to minus 0.2k, right? Okay, so this is what my C region lies. So now what happens? So basically what you can do, I want this A value to be C and to be critical point, right? So critical point should lie in this region, so I will change this with A with critical point basically. So minus 1 should be less than minus 8k, right? Okay, this is the first condition. So k, okay, what I will do, I will simply multiply minus on both sides, or I can swap, I can make my 8k in this right hand side and take this minus 1 on the left hand side. So this will become plus 8k and this one will become plus 1, but this sign will interchange, right? Like this flow of inequality will interchange, or if you multiply both sides with minus 1, then also this flow of inequality changes. So this one will become k less than 1 by 8, right? So this is the first condition, right? My k has to be less than 1 by 8 basically. Okay, so if my k is less than 1 by 8, then my system will be stable. Not talking about the infinity case, because infinity is not given. Okay, infinity is not given in the options, as you can see, right? Infinity is not given, right? So infinity is not given. Now what about the other case, right? The C case. So first I will solve this one, minus 2k less than minus 1. So I will again multiply with minus 1 on both sides. This will be k greater than half. And what about this one? This is simply minus 0.2k greater than minus 1, right? Again multiply both ends by half. So this is basically k by 5 equals to 1. So k has to be less than 5. So k greater than 1 by 2 and less than 5 is another condition. So these are my two conditions, k less than 1 by 8 and k lie between less than 5 and half, right? So these are basically what my two conditions represent. So is there any option present? So it is between half and 5. Okay, half and 5, and it is less than 1 by 8, right? So these are the options, right? So option B is the correct option here. So yeah, this is very good question. Okay, if you didn't understand it, we can solve it in other ways also. You just go to the different points, right? Different points and check for stability on the edge cases. On the edge cases, put k equals to 1 by 8, put k equals to half, 5. You check the edge cases and you will see different stability. But this is the most efficient way in which you can solve this question. Okay, in the best manner, what I can think, right? So this is the most efficient way. So yeah, this is it for this question. So we will end our lecture here only, right? Because like this lecture has already gone long and we have few still more questions left. So I will solve those questions in the next lecture. And yeah, if you like this video, then do please hit the like button, right? If you like the explanation, and if you have any more doubts, you can post it down in the comments or just put it down in the Telegram group, right? So thank you for watching, and I will see you in the next video.